right, our third day dealing with exponents, second with radicals here. So we're going to start the lesson talking for a little bit about what we talked about at the end of class yesterday. This whole radical versus exponent thing and how it works. So when we're looking at radicals, we talked a little bit yesterday about this little number that goes outside here that's called the root, also called the index sometimes. And then, of course, the value that's out here would be my exponent. And the only difference sometimes is sometimes we may have this where our radical value is in parentheses and then the exponent's outside. Or you may have it where the root value is still in the same spot, but now the exponent value is on the inside of the radical. For our purposes, when we're changing from radical to exponent, that doesn't matter to us. It will if we had to calculate something, though. So what we're going to do is instead of using this mathematical, yes, I'm going to call it mumbo-jumbo, as all math teachers out there cringe, using n for root and p for exponent makes no sense to me. So what we're going to do is we're going to say, okay, if this is our root and this is our exponent, we'll actually use those letters. And when we're going to the exponent, it's exponent over root. Okay. That is going to be what we kind of need to lock in on, because when we're trying to get this into a format where we could put it into a calculator or use our brain or use our newly found chart, okay, to our advantage, that's what we're going to be trying to do. So when it says find the indicated real nth root of, okay, a is just going to be my base. It's the number I'm going to put under the radical. And then n is going to be my root. So we talked a little bit yesterday about how I could take this radical and turn it into an exponent. That's what we're going to do right now. So I take my base. Now we just got done over here saying it's exponent over root. I see the root, but I don't see an exponent. So if I don't see an exponent, what exponent's actually there? 1. So what I would do in this case, unless I happen to know what the cubed root of 125 is, which again, I could use this to figure out that it's 5. That's for another time. I can go ahead and use the calculator on that if I so choose. Now, as we said yesterday, we don't want to be completely calculator dependent for everything, because sometimes there's going to be a variable term that I'm going to need to be able to deal with that the calculator won't do for me. But for our other times, this isn't a bad route to go. All right, we're going to try and avoid some glare here. We'll see how successful this is. Not very. Okay, let's come back down here a little way. So negative 125, I'll put it up just long enough to see. Again, if it's been a while since you've used these, my up arrow, my caret button just above the divide, that's how we get into exponent mode here. And then we just type in this case, our fraction, 1/3. Hit enter, we get our answer. And the same thing on the next one we get. Again, my a value is my base, what goes underneath. N is going to be my root value. And again, I just need to go in, turn it into an exponent, which will be easier for me to deal with. And again, if I don't see an exponent, we assume it's 1. And again, I can go to the calculator if I so choose. And get my solution. But the main thing as far as the radical to exponent we're going to be doing is kind of converting them back and forth from fractional, exponent to radical, and so on and so forth. So here, I've got radicals. We want to turn them back into their exponent format. So there's my base, there's my exponent, there's my root. That's all I'm doing. If I happen to get one when I do this, exponent over root, that reduces, like it would with any fraction. We like to reduce when we can. And that's always going to be true with any of these. Exponent over root. But then usually, I'm going to skip 6. Usually people get to 7, and that's where they're like, not too sure about this. What about if there's more than one thing going on? Just treat them separately. So I do my e, exponent over root. I do my f, exponent over root, not roof, no. I cannot put those together. I can't add their exponents because they're different bases. So that's all I can do. And what we also seem to do in here often is to do the opposite of things. So if I want to be able to go from exponent to radical, okay, I want to be able to go the other way as well. So, bump this up a little bit. Write each of the following as radicals. Now remember, when you're looking at these, your exponent and your root are both found in the exponent that you have here. Sometimes I even think it's easier if we label those before we start, just to remind me where the pieces go. So when I go to make my radical, my base value goes underneath. My exponent will go with it. My root goes in this little spot out here. Again, my root number is not a coefficient. It's not a big 2 out here. It's just that little 2 in there to remind me what that root's going to be. And I'm good. No different when it's a variable. Get the a under there. There's my exponent and root. And I'm sad. And we just kind of keep looking at it that way. 5 to the 2/5 again. 5 exponent root. Now, I'll have people ask me sometimes, and it's a legit question, well, what if I can actually simplify this? I mean, I know that 5 squared is 25. Can I do that instead? They're equivalent. I'm absolutely fine with you doing either of those. Okay? They both show me you understand the concept. This next section, I'm going into rebel mode, so don't tell anybody. Not that it's not going on the World Wide Web, but I'm just saying. Okay, we're going to evaluate these expressions. Now, I know it says let's try without a calculator. The initial thought when we were talking about this last summer was that we'd be able to take the chart, set these up, and get to the answers. But I understand the reality of things. Given the choice, you're going to use a calculator. I'm going to show you how to do it on a couple, but I still know more than likely how this is going to work. So here's what I was thinking when we did this originally. If I turn this back into a radical, okay, let's get my square root, I get my 9, there's my exponent, there's my root. The initial goal in doing it this way was you do what's in here first. The square root of 9 is 3, and then we would cube it and get our answer. But again, I understand reality. And reality tells me that most of you are just going to do this and get the same thing. Okay? Again, it's kind of your call on that. But here's the danger. There is one danger in using the calculator with these, and it actually shows up in the very next question. So 32 to the negative 2/5. Okay, I'm just going to type this in. Get a decimal. Nope. We don't do decimals. So if you're going to go this route, math, enter, you need to get it to a fraction. And what you're going to find out is negative exponents don't create negative answers. Negative exponents create fractional answers. So it also kind of lets you know if you've typed some things in right. So when we do it on 4 to the negative 1/2, it's the same thing. Now when you get your answer, basically all we're doing here, I'm going to do it like this one more time. Instead of the square root of 4, it would look like this. So there's my exponent, there's my root. And what would happen is, square root of 4 is 2. 2 to the negative 1. Remember, I can't do a negative exponent either. I got to flip it. And I get 1/2. The same thing that I get. Whoa, not negative 12. Nope. Not 0.5. 1/2. Okay. And then finally, just to show you, and you can punch this in, some of you probably already punched in the last two while I've been talking. You can get large numbers as well. You plug in 16 to the 5/2. Don't get freaked out if you start getting some larger numbers. That's okay. Just make it work, make it work, make it work. Okay. Now, just a couple down here left at the bottom, and then we're going to kind of work back into regular exponent mode for a little bit. We'll see these again. Use a calculator, it wouldn't have to be graphing, to approximate round answers to the nearest hundredth. So here, I'm going to need to be able to plug it in my calculator. So there's my exponent. There's my root. And especially these are going to be like decimally. This, ladies and gentlemen, when you see something like that, math enter isn't really going to help you. It's going to come back to this again. This is the one time when it tells you you're going to get a decimal, that it's okay to get a decimal. Otherwise, we shouldn't be doing the decimal game with these. And so our last thing, and this is where I get to make the connection back again with exponents and my exponent rules a bit before we go into review mode. When I get here, just keep reminding yourself, okay, whenever I see variables in these, just like we've said it probably a dozen times already, okay, when we're dealing with variables, we're going to do the exponent divided by the root. And remind ourselves, if I don't see an exponent, it's 1. So as I start to look at this first one, I'm going to write out all the pieces first, my exponent over root for each piece. As you get used to this more, you may not have to write it out like this. You may be able to just do it in your head, but for now, it's a good idea to leave it as it is. I'd go ahead, I'd punch the number part in my calculator, my 32 to the 1/5. That's going to come out nice. And so do the rest of them, because I can reduce their fractions. 5 divided by 5 is 1. 10 divided by 5 is 2. Okay, that wasn't bad. Even if it's something that looks kind of crazy like a fraction, same thing. Just keep doing your exponent divided by your root. Exponent divided by your root. And if they simplify nice and clean, that is just great. You're like, wait a minute, if they go clean, are you telling me they're not going to be clean every single time? I am. And actually, starting here at number 15, you're going to get to see what happens when they don't. So it looks a lot like 13 did. So when I'm first starting here, I'm going to treat it like it is. And lots of variables this time. So I start to look at this, and I punch in my 16 to the 1/4. Okay, that still came out nice, so it hasn't happened yet. 4 divided by 4 is 1. Okay, we're still going good. Then we get to E. Oh, E. I get to E, and I do 9 divided by 4, and I get a fraction. Well, I get a decimal. We don't do decimals. You're like, okay, I'll do math enter. Well, that gets me back to 9 over 4. Now what? Here's how this is going to work. Some of you may not have seen this in like years, like grade school. I don't even know when they do this anymore. We're going to do a little old school division. So we're going to take our 9. We're going to divide it by 4. So here's the question. How many whole full times does 4 go into 9? 2. So that is going to stay on the outside with all the rest of them so far. Okay, so it goes in 2 times. I got 1 left over. The leftover stays underneath the radical. Okay? So this, whatever my remainder is, stays under the radical instead of getting out. So if you... Oh, just stretch it out. Okay. And then f goes back to being normal. 20 divided by 4 is 5, but there's no remainder, so that can stay on the outside. So only the ones that don't go in cleanly, that have remainders, are going to end up with a piece that's under the radical. But that's when we say, however many times it goes in fully, that gets out. Remainders, those have to stay in. And we'll look at one more like that here momentarily, but I've got one other one here on the front we're going to do first. So our last one, a little twist again, we've got parentheses. Do I have to distribute the 32? No. We're going to leave that in the parentheses, and I'm going to do exponent over root. And again, luckily here for me, 4 goes evenly into 32. It goes in 8 times. And I'm going. So there's one last problem I want to do on here. It's on the back. It's the very last problem. It's kind of like 13 and 15 were. We're going to get to see this whole it doesn't go in evenly part one more time. So back here on 33, again, I'm going to set it up exponent over root for each of my values, just like I have on the other ones like this. And I notice right away as I start to look at them, hey, some of those I don't think are going to go in clean. So I'm going to get this part ready to go here. So I look at x. That doesn't go in even. So 4 goes into 5 once. So I got x to the first outside. But I got 1 left over. X to the first on the inside. And again, if you can do this stuff in your head, you don't have to put the stuff to the side, but I think it helps sometimes just to see it. 12 divided by 4 is 3. So again, when it's clean, it gets to stay outside. And then 21 over 4. Nope, that doesn't go in nice. 5. So my z to the 5 is on the outside. And we got 1 left over on the inside. Looks weird. That's the way it is. Okay. So like I said, these will be coming back up again once we get through our little review here of exponents here momentarily. So I still do want you to be looking at it, but just kind of get some practice too on the, let me pull this around. Maybe. Can I fit them all on one screen? I can. Okay. This is the homework that goes along with this. We're just doing the evens on worksheet B. We don't need overkill, but we need some practice. And we're going to be skipping number 24 because that's just a little over the top, and we're not going to be that over the top when we're doing these. So, properties of rational exponents, worksheet B, evens. And we'll be skipping number 24. As always, there's a key up front, so you can kind of check them as you go. Take a picture of the key to do it later, however you want to do that. But it's something you'd want to do with those.